Imagine a planet adrift in the vast expanse of space unbound to any star. A solitary world shrouded in perpetual darkness wandering the cosmos like a ghost ship. These are rogue planets, celestial nomads that have been ejected from their home star systems left to roam the interstellar void. These planets are shrouded in mystery. They challenge our understanding of planetary systems and the very nature of our universe. Rogue planets, also known as interstellar planets, are a fascinating and relatively new area of study in astronomy. They are not bound to any star, meaning they do not orbit a host sun like our own Earth. Instead, they drift through the galaxy, subject to the gravitational pull of other celestial objects. Their existence raises intriguing questions about planet formation, the potential for life beyond star systems, and the vastness of our universe. Unlike Earth, which basks in the warmth and light of our sun, rogue planets experience eternal night. Their only source of light and heat comes from the faint glow of distant stars and the potential internal heat generated within their cores. This makes them incredibly difficult to detect and study, as they emit very little light or radiation. The study of rogue planets is still in its infancy. However, what we are learning is challenging our preconceived notions about the universe and the potential for life to arise in the most unexpected places. To understand the anomaly of rogue planets, we must first understand how planets typically form. The birth of a star is a dramatic event. It is within these stellar nurseries, vast clouds of gas and dust, that planets are born. As gravity pulls the cloud's material inward, it begins to spin, forming a disk around the nascent star. Within this swirling disk, particles collide and clump together, gradually growing larger over millions of years. These clumps, called planetesimals, continue to attract more material, eventually forming protoplanets. These protoplanets, under the influence of gravity, clear their orbital paths, becoming full-fledged planets. This process of planetary formation, a delicate dance of gravity, accretion, and time, usually results in planets bound to a star. However, rogue planets tell a different story. They are evidence that the universe is full of surprises, and that the process of planet formation is not always so straightforward. The existence of rogue planets suggests that sometimes this delicate dance of planetary formation can be disrupted. There are two main theories about how these planets become cosmic wanderers. One theory suggests they form like stars, directly from the collapse of a gas cloud, but on a much smaller scale. The second, and perhaps more widely accepted theory, is that these planets were once part of a star system, but were ejected due to gravitational interactions with other planets or nearby stars. Imagine a game of cosmic billiards where planets are the balls and stars are the pockets. In this chaotic dance, a planet can be flung out of its system, cast adrift into the void. These ejection events are thought to occur during the early stages of a star system's formation, when the orbits of planets are still unstable. The gravitational tug of a passing star, or a more massive planet in the system, can be enough to fling a smaller planet out of its orbit and send it on a solitary journey through the cosmos. Finding these dark, solitary worlds against the backdrop of the cosmos is no easy feat. They emit no light of their own and are incredibly faint. For astronomers, discovering a rogue planet is like finding a needle in a cosmic haystack. However, astronomers have developed ingenious methods to detect these elusive objects. One such method is gravitational microlensing. This technique relies on the fact that the gravity of a massive object, even a rogue planet, can bend and magnify the light from a more distant star. By observing these brief, brightening events, astronomers can infer the presence of an unseen object, even a rogue planet, passing in front of the star. Another method is direct imaging, which involves blocking out the light from a star to observe fainter objects orbiting it. While this method is more challenging, it offers the possibility of directly observing the rogue planet itself. Life on a rogue planet, if it exists at all, would be unlike anything we can imagine. Without the warmth and light of a star, these planets are incredibly cold, with surface temperatures plummeting to hundreds of degrees below freezing. Their surfaces are likely covered in frozen oceans, vast plains of ice, or rocky, barren landscapes. However, the lack of a host star doesn't necessarily mean these planets are completely inert. Some scientists theorize that rogue planets could retain internal heat generated from their formation or radioactive decay within their cores. This internal heat could potentially support subsurface oceans of liquid water, shielded from the frigid temperatures at the surface. Furthermore, some scientists believe that rogue planets might have thick atmospheres that could trap some of the heat generated from their interiors, creating a greenhouse effect. This could potentially create more temperate regions on or below the surface, where temperatures are conducive to some form of life. Section 6. Life as we don't know it. The possibility of life on rogue planets. The possibility of life on a rogue planet challenges our understanding of what life needs to survive. On Earth, life is inextricably linked to the sun. It provides the energy for photosynthesis, the process by which plants convert sunlight into energy, forming the base of our food chain. However, life is incredibly adaptable. We've found organisms thriving in the most extreme environments on Earth, from the depths of the ocean floor where sunlight never reaches, to volcanic vents spewing scorching hot water. These extremophiles, as they're called, offer a glimpse into the potential for life to exist in environments vastly different from our own. On a rogue planet, without sunlight, life would have to find other sources of energy. Chemosynthesis, the process of converting chemicals into energy, could be one possibility. Some scientists believe that hydrothermal vents, similar to those found on Earth's ocean floor, could exist on rogue planets, providing a source of energy and chemicals for life to thrive. Section 7. Distant shores. The challenges and rewards of exploring rogue planets. The vast distances between stars and the faintness of rogue planets make them incredibly difficult to study. Current telescopes are not powerful enough to directly image most of these objects, let alone study their atmospheres or surfaces in detail. However, future telescopes, such as the James Webb Space Telescope, will be much more sensitive and will be able to detect and study rogue planets in greater detail. These telescopes could potentially detect the chemical signatures of life in the atmospheres of these planets, if they exist. Visiting a rogue planet is a challenge of a whole other magnitude. The vast distances involved would require technology far beyond our current capabilities. However, the scientific rewards of such a mission would be immeasurable. A rogue planet, untouched by the influence of a star, could provide a pristine glimpse into the early conditions of our solar system and the formation of planets. Section 8. Giants in the void. Notable rogue planets. While rogue planets are incredibly difficult to detect, astronomers have already discovered several intriguing candidates. One such object, known as PSO J318.5-22, is thought to be a gas giant about 6 times the mass of Jupiter, drifting through space about 80 light-years from Earth. Another intriguing object is CFBDSR 2149-0403, a rogue planet candidate located about 100 light-years away. This object is particularly interesting because it is relatively young, estimated to be between 50 and 120 million years old, which could provide valuable insights into the early stages of planet formation. These discoveries are just the tip of the iceberg. As our technology improves, we are likely to find many more rogue planets, each with its own unique story to tell. Section 9. Rogue planets in science fiction. Imagination runs wild. The idea of rogue planets, these dark, wandering worlds, has captured the imagination of science fiction writers for decades. They have served as settings for stories of exploration, mystery, and even horror. In some stories, rogue planets are depicted as desolate wastelands, home to strange and dangerous creatures that have adapted to the harsh conditions. In others, they are portrayed as potential havens for humanity, offering a chance to escape a dying Earth and start anew. One classic example is Fritz Leiber's 1951 novel, A Pail of Air, which depicts a rogue planet having been ripped from its sun, where the atmosphere has frozen to the ground. The story follows the struggles of a family trying to survive in this harsh, frozen world. Rogue planets, with their mystery and potential, offer a blank canvas for science fiction writers to explore themes of survival, adaptation, and the nature of life itself.